Hello. All right, cool. So for our Unit 5 assignment, we're going to be going over 4 quick questions, all involving derivatives. I'm just going to walk you through all the steps I've taken to solve each question and why we're doing so. So for our first question, number 1, it says determine the derivative of f at x equals x cubed over 3x squared plus 4x. So first things first, we notice that there's division involved. So right away that tells us that we're going to be using the quotient rule. We can also see that in both the numerator and the denominator here, we have exponents, so polynomials. So that means we're also having to use the power rule, where we bring the exponent down and take one off the remaining exponent. So my first step here was I subbed in my values for each. So in this quotient rule formula, f at x is the numerator, g at x is the denominator. I subbed in the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator all over the denominator value squared. I expanded the brackets through here, leaving me with this section here. Once I got this, I collected like terms to leave me with 3x to the 4th plus 8x cubed. Knowing this is squared, I expanded it, squaring using double the product, then squaring again to leave me with this. From here, I noticed I could sub out on the numerator x cubed. On the denominator, I could sub out x squared. The squared cancels and leaves me with x on the numerator here. My last step here was then to notice I could use complex trinomial, the complex trinomial method to simplify this. So I found two numbers that multiplied 9 times 16, which is 144, and two numbers that add to 24. Those found out to be 12 and 12. Yeah, and then I subbed those back in, common factored, had 3x plus 4, both in brackets common, and then 3x plus 4 out of brackets, which left me together with 3x plus 4 squared. And our numerator stayed the same at x bracket 3x plus 8. And my therefore statement is as follows. Alrighty, so for question 2, it basically, what it's asking here is it wants us to determine the equation of a tangent line to the curve f at x equals x minus 1 times x squared minus 8x plus 7 at the point x equals 2. It then wants us to find a second equation to f at x that has the same slope, so a second tangent with the same slope as the first. So our steps to do this are, firstly, we're going to want to find the derivative of our initial function. That way we have a way to calculate our slope. So we're going to do this by using a combination of the product rule, as we see two terms are being multiplied together, and the power rule as we see there's exponents. So in this case, f at x is the first term, g at x is the second. I found the derivative of the first term to be 1, multiplied by the second term plus the first term multiplied by the derivative of the second term, here using the power rule. For each, the 2 came down 2x, and then 1 came down -8, got rid of the x because less than 1 of the exponent. Anything exponent 0 is 1. I then expanded through the brackets, getting us to here, collected like terms, and it left me with a quadratic equation. This is now our derivative equation. I subbed in our point, x equals 2, and it left us with a slope of 9. Our next step is to find our line. We need 3 pieces of information. So my next step was to find our third piece, which is the y value of this point. So I subbed 2 into our original equation, and it left us with -5, thus being our point, 2, -5. So I subbed in our point and our slope into the y equals mx plus b equation to give us a b value of 13. That being said, we now have our first equation of a tangent, y equals -9x plus 13. Now knowing this, I set the slope equal to our tangent, since we have to find a second tangent with the same slope. So that means there must be 2 or more, but generally because it's a quadratic, 2 values of x where 9 is where it equals 9, where it's true. So I set -9 equal to our equation, brought it over, used the quadratic formula to solve, and it left me with an x value of 4 and 2. 2 is already the one we were given, So 4 is one we need to solve for. So I did the same thing, brought it over, subbed it into the original equation, got it to subbed in 4, and then we got negative 27. So our next point of tangent C was 4, negative 27. Now, using the same slope in this new point, our 3 pieces of information, I subbed that into y equals mx plus b, got a b value of 9, and they're giving us our second equation, y equals negative 9x plus 9. And those are our 2 tangents with the same slope. Alrighty, so our third question might look confusing at first glance, but let's look at it in a more simple way. Basically what this question is asking us for is it's trying to find the equations of lines that are tangent to this function here, y equals x to the 4 minus 6x squared, and also intersect a point off that function, so in our case 0, 3. So for this example, we need to find 2 methods of finding a slope equation. So our first is to find the derivative of this. So we use the power rule here and find it out to be 4x cubed minus 12x. Boom, that's our first slope equation. Our next one, we're going to use the slope formula with x and f at x being here as our first point and 0, 3 as our second point. And we subtracted 2, so subtract the y values over the difference in the x values. We sub in our initial function here, minus 3, x minus 0 is x, and we go through such and set our first way of finding slope, use that being the derivative, equal to this. Now we're trying to find those points of intersection, so those x values. Those x values are then going to help us to find our points of tangency with this function. Since we already know they're going to have this point in common, we need to find what two or whatever points intersect or are tangent to this function. So we carry through, we multiply this by x, get rid of the denominator, carry this over, collect like terms. We use synthetic division twice since it's a power of 4, and that leaves us with a root at 1 and a root at negative 1. So that means we have our 2 points of tangencies with x values of 1, negative 1. We sub 1 into our initial equation to get the y value of negative 5, negative 1 into our initial equation to get also a y value of negative 5. So we now have our 2 points. Once we have this, we're going to sub in our x value again, but this time into our derivative. Notice x or f at 1 primed. So this is going to give us our slope, negative 8 and 8. Now with these 3 pieces of information, we're going to sub this into our y equals mx plus b formula to get our b value. So we got our b values 3 and 3. And so we have our 2 final equations, y equals negative 8x plus 3 and y equals 8x plus 3. Very similar. However, these are different. Both equations will be tangent to this function. However, they will both also intersect the point 0, 3 off the function. And yeah, that was finding 2 tangents that intersect a similar point. Alrighty, so our fourth and final question. It looks like a doozy, but it's not too much to handle. What's asking for is us to differentiate or find the derivative of this long equation here and simplify fully. So basically what we want to break this down into is a bunch of chain rule questions all smushed together. So I added these lines here to help us kind of visualize which exponent is applying to which set of brackets. So the rules we're going to be using are chain rule and product rule. Chain rule obviously on the set of brackets, and the power rule inside each bracket. So for example here. So our first step is going to be use chain rule on the first set of brackets. So I like to think about it like those dolls that you stack one on side of each other. So there's a small doll on the inside, and then the dolls slowly get bigger until you have your outer shell. So right now we're cracking at the outer doll. We're going to bring that 5 down. It's going to end up here. And so chain rule states that we have, once we found the derivative of the outside, we lessen the exponent by 1. We then have to multiply it by the derivative of the inside. So it's going to be the next doll or the next bracket. Once we found this, outer one, we got to find the derivative of the inside, which is going to be chain rule again. So we bring the 3 down, constant cancels out, turns to 0, plus 1 is just 0 plus, so it's nothing. And lessen the exponent to 2 by 1 to 2. Next, now we got to do it again. Multiply by the derivative of the inside. So it's going to be our next smallest doll, which is our 9 bracket. So we're going to bring the 9 down. However, there's a trick here. This sets to 0 because it's a constant. However, this negative stays negative because 0 minus whatever still leaves a negative out here. So this is actually going to turn to -9. So be careful we don't turn that positive. That'd be a common mistake. So the 9 comes down, -9, less than the exponent by 1 to 8. And lastly, our smallest doll here, the 6 plus 7x to the 4, we find the derivative of that using the power rule to be 28x cubed. Our second line, all we're going to do is bring these values out. So the 28x cubed multiplies to the -9, giving us -252x cubed. The 3 comes out, and the 5 and 10 can multiply together to give us 50. Now we're left with 3 coefficients, or leading coefficients, 50, 3, and -252x cubed. We're going to multiply all these 3 together to give us -37,800 x cubed out front of our individual sets of brackets, which are going to be in order of descending exponential value. So our biggest set from up here is going to come down in front, our next biggest set down here, and our final set down here. This is as simplified as we can get it since these are all attached to exponents and we can't common factor out anything else. So our final answer is as this. Not too many steps in this one, but some places we could go wrong. And yeah, that's the end of our Unit 5 assignment. I gotta show my face.